video is to provide you with the classwork notes that you need for section 3.2.3. So we're going to continue to think about what happens when we remove positive and negative tiles from a collection of tiles, and then we're going to extend our thinking to find ways to make our calculations more efficient if we remove the same number of tiles multiple times. So first thing they want you to do is to predict whether these are going to be positive or negative. So I want you to look them over, pause the video for a moment, and predict what you think. Do you think each of these will be positive or will be negative? Once you're done putting down your predictions, I want you to write down this sort of shortcut way to subtract integers. We use a technique called keep, change, change. And that is something you should be putting into your not only notebook, but toolkit as well. So keep, change, change should remind you of when we did keep, change, flip for multiplying fractions, taking division of fractions and changing them to multiplication, or keep, change, change we talked about there as well. With the division of fractions, keep was keep the first fraction as it was, change was change the division sign to multiplication, and change or flip the second fraction, multiply as usual. With this is for subtracting integers. So I want you to put down keep, change, change for subtracting integers. Then, what are those steps? Well, the first keep is keep the first integer as it is. Meaning don't make any changes to it. Leave it as it is. The second, the change, is change subtraction to addition. That's why it's important that we get good at adding integers, because subtraction will get changed to addition. The third step, which is another change, is change the sign on the second integer. So if it was positive, make it negative. If it was negative, make it positive. And the fourth step is add as usual. So again, if you remember our keep, change, flip, it was keep the first fraction as it is, change the division sign to multiplication, change or flip the second fraction, multiply as usual. This is, again, meant to be sort of connected to that idea. Keep the first integer as it is. I'm going to get rid of the S there, so it will not be plural. Change subtraction to addition, change the sign on the second integer, add as usual. So if we start with A, keeping the first integer as it is means that we're going to keep -1 as -1. Then we're going to change the subtraction sign right there to addition. And then we're going to change the sign on the second integer. Well, the second integer is -6 5/10. Now we're going to make it +6 5/10. And then the add as usual is, well, what do we do if we're adding two integers? One's positive, one's negative. If they have opposite signs, we subtract them. So we'd get 5.5. And then we have to decide, is that going to be a positive 5.5 or a negative 5.5? And again, that's based on whether -1 is pulling harder in a negative direction or 6.5 is pulling harder in a positive direction. And of course, 6.5 is pulling harder. So our final answer would be 5 5/10. So you're going to do your rewrite, and then you're going to write down your answer. For the second one, keep the first integer as it is. Change the subtraction sign to addition. Change the sign on that second integer. It was negative. Now it's going to be positive. So if we take 2 2/10 and add another 2 2/10, our rules for adding integers, if they have the same sign, is we just combine them. Keep that sign, 4 4/10. So again, show your rewrite, show your answer. And then here, keep your 12.5 as it is. Change your subtraction to addition. Change the sign on the second integer. Right now, it's 22.5. 22.5 is considered positive, so we're going to make it negative. So we're going to end up with 12.5 plus -12.5, or pardon me, plus -22.5. So since they have opposite signs, we're going to subtract them. which will be 10. Is that going to be negative or positive? Well, 22.5 is pulling harder in a negative direction than 12.5 is in a positive direction, so it's going to be negative 10. And I want you to take a couple moments and see if you can figure out D, do the rewrite, figure out the answer, pause the video for a moment. Okay, then to check, negative 100 should stay as it is. Subtraction changes to addition, and 98 right now is negative, so we need to make it positive. So since they have opposite signs, we subtract, carry the sign of the number that is pulling harder in its direction. So there's your rewrite, there's your answer. Here, you could make this into negative 10 plus positive 2 plus positive 2 plus positive 2. Because again, all those subtractions get changed to adding the opposite. That's what this ends up doing. So if we have negative 10 plus 2 plus 2 plus 2, that's negative 10 plus 6, which is negative 4. Then we're going to look at the same problem that we talked about. How is a shorter way, or what is a shorter way that we can write that expression? Well, instead of thinking of it as negative 10 minus negative 2 minus negative 2 minus negative 2, we could think of it as negative 10, and I'm going to write this first, negative 10 minus 3 groups of negative 2. Okay, because we have 1, 2, 3 groups of negative 2. Well, if we do the rewrite for that, that is going to be what we have right here. Negative 10 stays as it is. Subtraction changes to addition. And the 3 times negative 2 becomes 3 times positive 2. That's changing the sign. So again, your answer will be the same. Here they want you to think about negative 7 times negative 11. Why is that going to end up becoming a positive answer? Now, you do not have to copy these down, but there's more than one reason why that's the case. One reason is we have a rule in math that a negative times a negative equals a positive. So, negative 7 times negative 11 would equal positive 77. Another way you can think of it is, think of it as the opposite of the negative. So if we had 7 times negative 11, in other words, if we just had this portion, 7 times negative 11, well, that 7 times negative 11 would be negative 77. And we know another way of thinking of the negative of that is the opposite of that. So the opposite of negative 77 would be positive 77. Opposite of a negative is a positive, so we can think of it that way. Or we can look at rewriting this. Instead of being negative 7 times negative 11, we could think of it as 0 minus 7 times negative 11. And if we did our keep change rule, 0 would keep as it is, subtraction would become to addition, and then the 7 times negative 11, or negative 77, would become the opposite or positive. So when you're going to answer these, what we want you to remember, and this should go into your toolkit, is a positive times, let me try to find a sign we can use for that. Positive times a positive will equal a positive. And like I said, this should not only go into your notebook, but also your toolkit. A negative times a negative will equal a positive. And if we have one of each, negative times positive or positive times negative, it will equal a negative. Now, one way we sometimes remember that is with a visual representation. I have it on my wall, but you certainly don't have to use it. But if it helps you to visualize that, you're certainly welcome to do that. So I'm going to put this here. positive. Okay, so let's do the first one. Positive times positive equals positive. So one way that we can think of that is a positive sign times a positive sign gives us a positive answer. Okay, so it's meant to look a little bit like a face. Or this one, a negative sign times a negative sign equals a positive. Okay, so again, the eyes are open or the little cross marks, positive. Eyes are closed, going to sleep, positive. But when we have one of each, positive times negative or negative times positive, it doesn't matter. But when we have opposites, that's what we call a negative. So again, the idea is just to give you a visual representation to help you remember. Now, this is true for multiplication and true for division. It is not obviously true with adding or subtracting. So we need to make sure that we're clear on the fact that these rules only apply when you're multiplying or dividing integers. Now, based on those rules, I want you to figure out what the answers are here. So take a moment, pause your video, and see if you can figure it out. So positive times negative should give you negative. Negative times negative should give you positive. Negative times positive should give you negative. Positive times negative, negative, negative times negative, positive, negative times positive, negative. So hopefully you got those all correct. I'm not going to have you worry about 356. It just talks about the mathematics behind why that works. And I do want you, though, to, again, try these. So 45 divided by negative 3, negative 32 divided by negative 8, negative 54 divided by 6. Pause the video, see if you can figure them out. And then, again, if you are having trouble, then check your answers. So these are the correct answers. Again, positive divided by negative, negative, negative divided by negative, positive, negative divided by positive, negative. So you should also look at your math notes, but again, make sure you have information in your toolkit to help you out.